Okay, we're going to talk about the population lab. That's what's this week. So hopefully at this point the students have all been keeping track of their fruit fly populations by putting little dots on the sides. And the fruit fly populations should all be pretty much dead now. Oh, they definitely should be dead now. And so for the lab tech, after this lab is over, all of those jars can be cleaned out because we're done with them. And you can clean the markers off the side of the jar. Alright, so for this lab, they're going to use their fruit fly populations. Wow, that's a tough one. They're going to use their fruit fly populations to be a model of population growth. And actually, their populations that they've grown in the lab, they will do exponential growth, and they will do logistic growth, and then they will crash. So we're going to use parts of it to do each thing. All right, so you're going to start out by having them all go get their jars, and hopefully each group had a big and a small jar and a vestigial and a normal winged fly in the different jars. So you have some variety in your groups. It's okay though if you don't. They are going to share throughout the classroom, so it's not that big of a deal, but it would be nice if at their table they have a couple different jar types or fruit fly types. Alright, so have them just read the introduction to the lab and then do number 1. So number 1 asks them, if you start with 2 flies in the jar, they have about a 1-week incubation time. It's really more like 2 weeks, but 1-week incubation time. They're making 10 babies with every pair in that 1 week. How many fruit flies would you have after a week, after a month, after 4 months? And so the students should be able to say, if I've got 2 flies and the 2 flies have 10 babies, right? Then after 1 week, we should have 12 flies. And then if these 12 flies get together into 6 pairs, and each of those 6 pairs have 10 babies, then we're going to add 60 babies the next week, and you'll end up with 72 flies. And if those 72 flies all get into individual pairs, do you see what I'm doing? So, but let the students figure that out. You'll end up with a whole bunch of babies, and end up with 432 flies by the end of that. And then it asks them too, what would you have to do in order to keep the populations growing indefinitely? So the students should start to be thinking about, well gosh, why did ours die? Well, they probably need more food, they probably need more room. And so you can sort of start to talk about, when you have a discussion about number 1, you can start to talk about limiting factors. But don't go into a lot of detail there because we are going to talk about it later. But just have a discussion about your flies. What happened to their populations? They died. Why did they die? And just start them thinking about that. Okay, and then once you've had a little mini discussion about that, then you're going to have them do steps 2 through 5. And I'm just following along on your instructor guide. So this is all very clear on your instructor guide. And so they're going to share their data. And so on this data table, on their lab manual, they are going to do the 4 members of their group. If they don't have 4 members in their group, they're going to do however many members they have in their group. But they're going to get some other data written down and make sure they label the topic. This was the small jar with the vestigial winged flies, and this was the large jar with the normal winged flies, etc. Okay, so they're going to write down everybody's data. That might take them a few minutes to get the data written down. And then number 3 asks them to actually do the calculations just like we did here and fill them in on their table under the expected numbers. So see the expected numbers. The expected numbers are based on, it tells them in number 3 that every fruit fly couple is going to have 10 babies, that it's going to take them 1 week, and that no one's going to die. And so using that, they can get a list of expected numbers. Okay, so the expected numbers are pure just math, and they're just taking it and multiplying it by the 10 babies and the 2 flies, and they're getting these numbers, so 10, 60, 360, 2, 12, 72, 432. It's in your instructor guide. You've got the numbers. So you're going to be walking around helping the students, making sure that they're doing the math right and all of that. So yeah, and really the easy way to do this is that because only half of them are produced, it takes 2 to produce the 10 flies, then technically it's 5 flies or 5 babies per fly. So really all you have to do is multiply by 5, right? 5 babies per fly, and get the next number of 432 total, 432 babies. And that'll give you the number of babies, and then you add that, and that gives 432, etc. Okay, so that's number 3. And then number 4 says for them to graph it, and now I want to point out really quickly on the student guide, and I should have fixed this, and maybe I will for next semester, so if this is already fixed, just ignore this. But on number 4, it asks them to graph the ideal, the expected population size, along with the different generations on the one graph. They're going to do that later, so it should just say, using the graph paper below, so this graph right here on the next page, they should just be graphing the expected. Just these numbers that they got, that's the only thing that should be graphed on that first graph. And it should look something like this. Okay, and let them struggle with graphing. Graphing is one of the skills, the learning outcomes of this lab. So, and students are really kind of bad at it. So help them, figure out what axes they need if it's going to get up into the thousands and thousands. And you can tell them, they can dot, 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 that it's going up into forever. But they should get a graph that looks like that. Okay, and so then it asks in number 5, it says, how do the slopes change? Okay, so they should be able to figure out, where's that table? On number 4, it asks them to actually calculate the slopes. So if they don't remember slopes from a long, long time ago in their elementary, slope is rise over run, or the change in x over the change in y. Okay, that's how we figure out slope. And in this case, the change in x is the number, number of new flies. The change in y is time. Okay, and in this case, we're just going to call it generation. So we're going to call this one generation. With every one generation, how many new flies do we get? With every one generation, so the change in y is just one unit. 1 generation, 2 generations, 3 generations, 4 generations, which turns out to be weeks for these fruit flies. So week 1, week 2, week 3, week 4. Okay, and what they should notice, if they figure it out, so between weeks 1 and week 2, the slope is 10. 10 new flies, okay? 10 new flies in that 1 week time. And then the next one, between week 2 and week 3, they're getting 60 new flies in 1 week's time. Between week 3 and week 4, they're getting 360 new flies in 1 week's time. Between week 4 and week 5, they're getting 2,160 new flies in 1 week's time. And so you can see that gradually the slopes are getting steeper and steeper, okay? Which makes logical sense. I know students sort of get freaked out about the math. They're like, oh, it's math, I don't know what to do. Just say, step back and think about it for a second. What does an increasing slope mean? An increase in slope means we're literally adding more babies in the 1 week's time. So the slope goes up, we're adding even more babies in 1 week's time. And if you think about it, the more flies you have there, the more babies you're going to have. So this is not a hard concept, it's just when you throw math in, students think it's hard. So you're just going to make the point on number 5 that we're adding more babies with each week because we're getting more flies. Okay? The other thing that you want to, no, not that right there. The other thing you want to point out is the shape of this curve. So we call it a J-shaped curve. And a J-shaped curve is exponential. Okay, and surely they can understand that out of 2 flies you got 10, and then out of those 12 you got 72 or 60, and so you get 72. So it's going up exponentially. It's growing exponentially. Okay? All right, I'm going to pause there to the next segment.